Good evening, everyone. My teammate Sammit and I, Ruchita, will walk you through our project, TalkMaster, an AI assistant for speedy technical support. Let's talk about the what, why, and how of our project. What is Tech2U? We both work for Tech2U, which is a program offered by the Learning Space Management to humanize the technical support. This is a typical work process. TalkMaster receives a call from a class, thinks of a possible solution to guide remotely. If they cannot solve it, they will send a staff to the room. Now, why we need this project? As you can see, the current process is time-consuming and requires an experienced personnel to solve the problem. Hence, we have a personal motivation to solve this issue. How are we addressing this? We are leveraging the capabilities of a large language model and building an AI solution to assist in the decision-making. This is a solution architecture. Our system will consist of two tasks. First task is of classification, whether a staff is supposed to be sent to the room or not. If not, we will come to a second task, which is using a retrieval augmented generation to provide the solution for the problem. Our input to the model is the issue being faced with the room number, and outputs are the labels 1 or 0, and if 0, what is the solution? Now, coming to the classification task, we trained our model on the daily TalkMaster data. Under pre-processing, we performed removal of any false alarms and other similar non-relevant information, along with some non-numeric values and undefined values. After that, we performed labeling of data for a send staff to room label, and we also cleaned the text from punctuations and converting into lowercase for better comparison. Our model and training. We use the base model as Tiny GPT-2 for our classification, and we trained that model on a custom classification dataset with description of problem as our input and send staff to room as our output label. As classification result, we received decent progress. Training accuracy was 82% and validation accuracy was around 73%. For the loss curves, we can see that the training loss exhibits a steady decrease along epochs, which means that our model indeed is effectively learning over the training data, and validation loss is also decreasing, which means that it performs well on the unseen data as well. This is on test on some prompts. The first one, as you can see, I'm in room SS 1069. My classroom speakers are making a buzzing noise. This statement doesn't call for a staff to be sent to room, hence the predicted label is 0. For the second example, you can see the batteries word in the prompt, which is clearly a delivery, hence the predicted label is 1. I pass on to Sammit.
So the next part of our system is RAG, retrieval augmented generation. Here is a overall architecture of the system. As you can see, we have a data ingestion pipeline, which is collecting data from our knowledge base and then cleaning the data, chunking them, and storing them in a vector database, at which point when a user queries something, we will get relevant nodes and do a post-processing on them, and then pass all of the query and post-process nodes to LLM, and we'll have a response synthesizer with the help of LLM, and that response will be shown to the user. These are some technical details. For the data cleaning, we had some redundant features on every page of the document, so we cleaned them, and at the end of document we had a table which showed editing history of the knowledge base, so we had to remove that because it consisted the names of people who worked on that. For the LLM, we used Llama 2 7 billion chat model. For the LLM orchestration library, we used Llama index. We chunked the documents into size of 200 with a 10% of overlap. This is our embedding model. We selected it from the massive text embedding benchmark leaderboard. It was 5th till yesterday, and now it's 6th on the leaderboard list. And next, moving to results and evaluation. For the evaluation of RAG, we decided we would rate it on relevancy. So human judgment on relevancy is our metric, and we got around like 80% inter-rater agreement. And here are some examples. There's an example of success and there's an example of failure. This is not exactly failure. I just created this prompt because we had a document in our knowledge base for a specific room which said this room does not belong to our department, but if you can't solve this remotely, just call this number. There was a number here. I deleted it. I was hoping that model will, as a last resort, will fetch out the number and give it to user, but it did not. So I just marked it as failure. And for the learnings of this project, despite the size of classification model, it gave really nice results, and it did learn some things, like if there's a word called batteries in the query, it's straight away label is 1, so it's sent staff to room. For the RAG model, it got to know there's a button from which you can turn on and off the projector in a room remotely. And with all this experience, if we have to do this project again, we might think of eliminating the classification task at all and just do advanced RAG with more than one indexes, which has one index for structured data, one index for unstructured data, and maybe transform queries using advanced GPT-4 and like LLM re-rank, use LLM into post-processing of nodes more. That's all. Thank you.